Hello and welcome to LFI Educates. Today we are in this kinematics branch of mechanics, motion in a straight line. Today we will discuss about uniform motion and non-uniform motion. Let us see first about uniform motion. A body is said to be in uniform motion if it covers equal distances in equal intervals of time. If a body is moving, suppose a straight path, starting from here, say 1 kilometer, this is 2 kilometer, this is 3 kilometer, this is 4 kilometer, this is 5 kilometer. Equal distances, if it covers equal intervals of time, suppose the time taken is suppose say 1 hour, here also time taken is 1 hour, here also time taken is 1 hour from 2 to 3 kilometers, then from 3 to 4 kilometers is also 1 hour. Here also you have 1 hour. Then you can see very clearly that all the distances are equal, 1 kilometer, 1 kilometer, 1 kilometer, 1 kilometer. It is taking equal intervals of time, 1 hour, 1 hour, 1 hour, 1 hour. Then the body is said to be moving in uniform motion. If you plot a graph, we call it as position time graph. And plot time along x-axis and position, and marking it as x along y-axis. Then what you can see is time as I have taken in hours. I will take 1 hour, 2 hour, 3 hour, 4 hour, 5 hour, 6 hour. Time is in hours. And the position or distance we are taking this in kilometer. You can mark it as km, kilometer. Here 1 kilometer, 2 kilometer, 3 kilometer, 4 kilometer, 5 kilometer, and so on. And if I plot the position time graph of a body in uniform motion, you can see like this. I'll get, if I make a small table, this is position time, this is position representing with x and time representing with t. Then first 1 hour you have traveled 1 kilometer. Then in 2 hours you have traveled 2 kilometer. In 3 hours you have traveled 3 kilometer. In 4 hours you have traveled 4 kilometer. This one, if I plot it in this graph, which is popularly known as position time graph, you can see here first kilometer, first hour 1 kilometer. So I will raise up by 1 kilometer from 0 to 1. It will come here. Next 2 hour it has traveled 2 kilometer. So it will come like this. Like this, if I go on plotting 3 hours 3 kilometer, 4 hours 4 kilometer. If I plot in this position time graph, I will get an inclined straight line. So it is also known as, in physics we call it as directly they are proportional. As time increases, distance is also increasing. So you will get a graph of this nature. Like this, 1 mark question may come in exam. What is the position time graph for a body in uniform motion? Then what you will have to do is, you will draw like this. This is the graph. The nature of the graph will be an inclined straight line for uniform motion. When we discuss about, now let us say about non-uniform motion. We are discussing now about non-uniform motion. A body is said to be in non-uniform motion. A body is said to be in non-uniform motion if it covers equal distances in unequal intervals of time, or unequal distances in equal intervals of time. In both the ways you can say time keeping constant, change time, equal distances in unequal intervals of time. If a body covers equal distances in unequal intervals of time, then the body is said to be in non-uniform motion. In such a case, the position time graph, if you draw, then it will be a curved line. It will not be an inclined straight line. It may go like this, or it may go the other way also. It depends upon this one. Equal distances in unequal intervals of time. Or you can even say if a body covers unequal distances, if you write, then here it will be equal intervals of time. So in such a case, the body is said to be in non-uniform motion. Now the next thing that we are going to learn is about speed. Speed and velocity. Let us see first what is speed. Speed is nothing but distance traveled by the body per unit time. It is defined as distance traveled by the body in unit time. Mathematically, you write speed is equal to distance traveled divided by time taken. Time taken, distance traveled by time taken. The SI unit of speed is distance, SI unit is meter, time is second, so meter per second. Meter per second, in short you write m per oblique you write and then s, or meter per second you can write like this also. And the dimensional formula of speed, it is MLT, write down, mass not there, length is there 1, time is to the power minus 1. This is the dimensional formula, and speed is a scalar quantity. It is a scalar quantity. You can see very clearly distance is scalar, time is also scalar, so it will remain as scalar. It's a scalar quantity. Here the definition is distance traveled by the body in unit time, that we call it as speed. Suppose I am moving from here to the end of this board. Then if I have a stopwatch with me, how long do I take? Suppose 1 meter I have moved. If I have moved 1 meter, So speed to calculate, you need to know these two physical quantities. Distance traveled, suppose 1 meter I have moved. How long I took? Suppose say 2 seconds. Then it will become 1 by 2, 0.5 meter per second. That I have moved with this speed, 0.5 meter per second. So if you have a stopwatch with you, and if you know the distance that you are traveling, if you divide them, distance by time, then you are going to get the speed, at which speed you have moved. That we call it as speed in physics. The next term that we learn is about velocity. It is also speed, but it has specified direction, as it is a vector quantity. Speed in a specified direction, velocity. Speed, it is defined as speed in a specified or specific direction is known as velocity. As you know, velocity is a vector quantity. Velocity, you can even define like this: displacement. Displacement is a vector quantity we have discussed earlier, divided by time. How much the body got displaced in how much duration of time, that will give us the velocity. Because of this displacement vector quantity, time is scalar, so velocity is a vector quantity. The SI unit of velocity is also same. The units are same. Dimensional formulas are also same. This one is different. It is a vector quantity. So this is for velocity. If I make it, SI unit of velocity is meter per second. Dimensional formula of velocity and then it is a vector quantity. You can define speed in both the ways. Speed in a specified direction is known as velocity, or you can even say that the rate of displacement of the body, rate of, the word rate is divided by time in physics. Rate of displacement of the body is known as velocity, or you can say displacement of the body per unit time is called velocity. So in all the three ways you can define velocity. These are the units and the dimensional formula. Now let us see about uniform speed and non-uniform speed. So if you remember the definition, you can define it very nicely. It is distance divided by time. A body is said to be in uniform speed if it travels equal distances in equal intervals of time. That we have come across, uniform motion. The same definition you can use for uniform speed as well. If it covers equal distance in equal intervals of time, then the body is said to be in uniform speed. And likewise, non-uniform speed if a body travels equal distances in unequal intervals of time, then the body is said to be in non-uniform speed. Definition matches with non-uniform motion. Uniform non-uniform speed and uniform non-uniform motion definitions are same. Only the terminology you have to change it. Speed. Before you use motion, now you use speed. Now let us define this velocity, non-uniform velocity first. Velocity, the definition says displacement per time taken. How much the body gets displaced in certain duration of time. That we call it as velocity. So uniform velocity, you will say like this: if a body undergoes equal displacements in equal intervals of time. Remember the formula and then say equal displacements in equal intervals of time. then the body is said to be in uniform velocity. Whereas non-uniform velocity is that velocity if the body covers unequal displacements in equal intervals of time. Then the velocity is said to be non-uniform velocity. Here you will have to use the word uniform velocity and non-uniform velocity. You will have to use the word displacement. These are velocity is displacement divided by time. So equal displacements in equal intervals of time, then you will get uniform velocity. Unequal displacements in equal intervals of time, you will get non-uniform velocity. Like speed, this is speed is distance by time. So here if equal distances are travelled by a body, or if the body covers equal distances in equal intervals of time, you get uniform speed. If the body covers unequal distances in equal intervals of time, you get non-uniform speed. So I think it is clear to all of you. So here is one question you can solve like this. A train 100 meter long moving with a speed of 60 km per hour. Speed, you write down, speed is equal to 60 km per hour. You have to change it into SI unit. 60 into kilo means 1000, multiply by 1000, then it will become meter. And 1 hour is equal to 60 into 60 seconds. So if you cancel this, 0, 6 tens are 60, 2 3s are 6, 2 5s are 10, then you will get 50 by 3 meter per second. In what time shall it cross? They are asking us to find out the time. How much? A bridge 1 kilometer long. So suppose this is your bridge 1 kilometer long. So 1 kilometer is equal to 1000 meter. This is a train. Just think that this AB is the train. B is the head of the train. A is the tail of the train. It's 100 meter long. So to cross the bridge, this head, first we have to travel this 1000 kilometer, 1 kilometer, this is 1000 meter. Plus this train should come here to cross completely. B should reach here, A should reach here. So become, this is a 100 meter long train. Sorry? Yes, it is 100 meter long train. So if you look carefully, from here if it travels, this much distance it has to travel, and then the B should go up to this end. Suppose say K and M. Total distance travel will be 1000 plus 100 meter. That will become 1100 meter. That is the distance. Distance is equal to 100 meter plus 1000 meter. It will give you 1100 meter. Now after knowing this, distance, time, speed, you can use this relation. We know that speed is equal to distance by time, or you are going to find out time. So you can write time is equal to distance by speed. Then you can put the values and you can calculate it. Distance is 1100 meter. Speed in SI unit is 50 by 3. Divide by 3 which will come here. That is your meter per second. Second also will go up. Meter you can cancel. 5 2s are 10. 5 2s are 10. 22 into 3 is 66 seconds. Like this you can calculate the time using the relation speed equal to distance by time. Average speed and average velocity. Average speed, when we say, it is the total distance traveled per total time taken. Average speed is defined as the total distance traveled by an object per total time taken. So to find out the average speed, you need to know the total distance and the total time taken. Average speed mathematically we write it as total distance or total time taken. Suppose the total distance, the individual distances are S1, S2, S3 and so on, or S1, S2, S3 say. The total distance, you will add it up simply, S will become, total distance, S will become S1 plus S2 plus S3, and if the time interval for distance S1 to travel is T1, for distance S2 to travel time interval is T2, for distance S3 to travel time interval is T3, total time T will be T1 plus T2 plus T3. After adding them, total distance and total time, after adding them, if you plot it here, then you get the average speed. Now, when we discuss about average velocity, it is defined as change in position. Change in position. And as we all know, the change in position means displacement. We write it as delta x, change in position. With respect to change in time, or divided by change in time, let us write it as delta t. So average velocity, V average also we write, that is delta t, change in position, displacement delta x by delta t, or we write it as final displacement, final position minus initial position divided by final time minus initial time. That gives us the average velocity. So let us do one numerical, then it will become more clear. So here is one question which will make your terms clear. Let us do the solution. A car is moving along a straight line, say OP, from O to P. In the given figure, it moved from O to P in 18 seconds. From O to P, time taken is 18 seconds. From O to P. And returns from P to Q. Again, it goes like this and comes back from P to Q in 6.0 seconds, that is 6 seconds. What are the average velocity and average speed of the car in going, two times I have written, in going from O to P. From O to P, let us see first case, from O to P. Average velocity and average speed you have to find out. Average velocity is change in displacement divided by change in time. In the definition also, if possible, instead of writing with respect to, you better write change in position divided by change in time. This way you write down. Then change in position, when you see from O to P, final position is 360 minus initial position is 0. This is along the plus direction, you will get it, positive you will get it. Displacement is in the positive direction, divided by change in time. So change in time, here you have from O to P, it took 18 seconds. and from, yeah, it took 18 seconds, so it will be change in time is only 18 seconds. So you can write this as 360 divided by 18 to the 36, so it will be 20 meter per second. These values are given in meter and time is given in second. So it will look like this. And when you do average speed is total path length, total path traveled divided by total time taken. Total path length is how much? Then from O to P, total path length is 360 meter, nothing to add. And time also it will be same, 18 seconds. So this also will give us 20 meter per second. Sometimes average velocity and average speed both will be equal, and for that only we are doing this question. In the second case, we see that average velocity and average speed will be different. Sometimes it will be equal, sometimes it will be different. Let us see the second case, from O to P and back to Q. The second case, from O to P and back to Q. Let us see. In this case, average velocity, there is change in position with respect to change in time. Now, change in position here you can see from O to P and from P back to Q. So this is the final position, 240, initial position is 0. So it is 240 minus 0 meter divided by change in time. Initial time we know it is 0. The final time is 18 plus 6. 18 plus 6 is how much? 24. 24 minus 0 second. So it will become 240 divided by 24, you will get 10 meter per second. Whereas average speed equal to total distance divided by total time. And in this case, total distance from O to P and back from P to Q is 360, and from 240 to 360, 120. 360 and this side coming 120. This distance is 120 meter. 360 plus 120. 360 plus 120 meter, and then total time 18 seconds, and to come back it is 6 seconds. 18 plus 6. 18 plus 6 second. So it is 480 divided by 24 meter per second. Meter per second. So 24 2 times is 480. So you will get 20 meter per second. So here you can see very clearly that sometimes average speed, average velocity both are equal, whereas sometimes average speed and average velocity it may be different as well. Let us discuss about these two terms, instantaneous speed SI we write and instantaneous velocity VI. Instantaneous speed is the speed at a certain moment of time or at a certain instant of time. The speed we call it as instantaneous speed. Instantaneous speed we write as SI. It is denoted with a limiting value of delta t as it approaches to 0. The average speed delta s delta t, or we say it as ds dt. The differential from ddt of s also we can read, or ds dt also we can say. So if you differentiate average speed with respect to time, then you get instantaneous speed. Suppose I am inside a bus, a driver is driving the bus, we are traveling from here to Chungkilima. Now when the bus is in motion, suddenly I wanted to know the speed at a certain moment of time. Say after reaching New Market area, I wanted to know the speed. Then when I look at the speedometer of the bus, suppose it is showing at 60 km per hour. In that moment, the speed is 60 km per hour. So the 60 km per hour will become my instantaneous speed. During that time, when I have looked, it took only fraction of second. That means it is nearly equal to 0. Time is approaching nearly equal to 0. That moment, the speed, we call it as instantaneous speed. We write like this as delta t approaches to 0. Now this one you have to do differential form. Now, differential calculus, that little bit you have to know. In mathematics you learn in class 12. Differential calculus, when we say, it is to make a big object, or you can think as an object. When you cut it into small pieces, part by part, if you cut it, that we call it as differential. Big thing, making it into small pieces, multiplying it into small pieces, that we call it as differentiation. Now, differentiation, you learn these few formulas. Suppose d dx of, with respect to x I am taking here, this is x to the power n, as an example. Then this n power will come here into x to the power n minus 1. This is the formula. Or ddx of constant term, say 7 or 8, like this constant term, if you get, it will be always 0. That means there is no x to differentiate it. Here you have x, so we are differentiating with respect to x, so you get the result like this, n into x to the power n minus 1. This formula, if you know these two formulas, then you can easily find out the instantaneous speed. The same way, this instantaneous velocity of an object at any instant of time, that gives us the instantaneous velocity. If I write vi, the instantaneous velocity, it will look like this. In limit form, if I write limit delta t as it approaches to 0, change in position, here you need to be very careful, change in position with respect to change in time, that we write as ddt of x. This is position. Change in position with respect to time gives us the instantaneous velocity. This one also the same way, you have to know the formulas to deal with this. Let us do some one or two questions, then it will become more clear how do we do this differentiation, then you will get the idea. But you have to keep by heart this one. If you are doing here time, then here also it should be time variable. If it is not a time variable, then it will become constant. If it becomes constant, it will become 0. You will have to keep in mind this one. But in this case, we will be differentiating with respect to time. Here the speed should be expressed in terms of time, then only you can differentiate it. Let us do some questions. So here you can see one question. If the average speed of the particle is given to you like this, average speed, let us write it as s, is given as 2t square plus 3t. Like this they will give you, sometimes they will give you even unit also, suppose this is in meter per second. Then find out the instantaneous speed of the particle. Now to find out the instantaneous speed, you can see that it is, the time is not given to you. So it is given in two parts. Then you will understand that I have to do part by part. That means I have to do differentiation. So how I'll do is, SI I'll write in the formula ddt of s. So ddt of s, ddt I'll write s, the average speed is 2t square plus 3t. Now together you cannot do, you have to do ddt of 2t square and plus ddt of 3t. Like this we have to do it in two parts. Then we will use, this will become 2 to the power 4, 3 to the power 2 minus 1, plus here power is 1, so 1 3 is 3, 3 to the power 1 minus 1, so it will become 4t, 2 minus 1 is 1, plus 3t power 0 will become 1, 1 into 3 will become 3, so it will become 4t plus 3 meter per second. Like this you can solve it. Now let us see one more question for average, instantaneous velocity. Question: related with instantaneous velocity. The displacement in meter of a particle moving along x-axis is given by, so x is equal to 18t plus 5t square. We are asked to find out the instantaneous velocity at two different time intervals, t equal to 0 second and t equal to 2 seconds. So first of all, what we have to do is instantaneous velocity. We will first find out vi. Instantaneous velocity will be ddt of position, that is x. Write down your formula. Then what is x? We will put it here. ddt of x is 18t plus 5t square. Then you will differentiate into parts. This is 18t and ddt of 5t square. Then we apply the formula for differentiation. Here power is 1. So 1 into 18 is 18. Then t will vanish. 1 minus 1 plus, here it is 1 and according to formula it should be minus 1. Here ddt of 5t square. So 2 5s are 10. T to the power 2 minus 1. So it will become 18. T power 0 will become 1. So it will be 18 plus 10t. Power 2 minus 1 is 1. So t will remain. Like this, first we find out the instantaneous velocity. After you find out the instantaneous velocity, at t equal to 0 we will find. At t equal to 0, instantaneous velocity vi is equal to, you put it here, 18 plus 10 into t is 0. So it will be 18 plus 0, it will be 18. And velocity we will write meter per second. We will write meter per second the unit. And at t is equal to 2 seconds, vi, the instantaneous velocity will be 18 plus 10 into time. In place of time we put 2. 2 times are 20. 18 plus 20 is equal to 38 meter per second. Like this you can find out the instantaneous velocity. Thank you and have a very nice day. Stay tuned to LFI Educates.